Welcome to TinCellWorks Products Demo Video Series. This particular demo video is designed to showcase some of the basic features of USMC, Universal Smart Machine Controller. It demonstrates how USMC is used to control the combined usage of analog and digital signal processing in this water level demo. The demo setup. The basic apparatus that are used as follows. Control panel, where the first red button will be used to start the process. The control panel wires to the distribution panel, with 68-pin SCSI, 2 connector attached to the USMC. Water level sensors in blue tank and red tank are used to generate an analog input signal, which will measure the water level. Digital outputs, in the form of 2 units of digital drivers for the water pumps, are also used to pump the water from blue tank to red tank, and from red tank to blue tank. Both are connected to the distribution panel. We are using a laptop, where USMC configurator software is already installed. Its purpose is to generate the machine program file using only a set of menu-driven actions, without a single line of coding required. Once the machine program file is generated based on the algorithm of this demo, it will be stored into an SD card, and will be transferred into the SD slot on USMC device. Once the reset button on USMC is pressed, the algorithm will be executed to perform the task. The program aim, the algorithm. The tasks designed for USMC here are as follows. Once the red button on the control panel is pressed, the water in the blue tank will be pumped into the red tank, until it reaches the desired water level. Once the water level is hit, the pump in the red tank will pump the water back to the blue tank to the initial level. Programming the algorithm. This is the USMC configurator software. Each step in this software must be completed before moving to the next step. The first step is to name the project detail, in this case we just call it SMC. The second step is to create a list of processes that the project will perform. Initial process here is a standard initialization process that has to exist in any project. We also include here what we call as run pumps, where the hardware module will be defined in the next step. We are free to call these processes any name we wish. Step 3 is where we have to include which hardware module that will be used in the processes that we have listed earlier. In the future, we will continue adding more hardware modules that USMC can and will support. In this video demo, the needed hardware modules are water pumps for red and blue tanks as digital outputs. We are going to go ahead and add these modules and the parameters, for they have to be defined. The next step is to add the water level sensor modules as the analog outputs. We call them sensor high and sensor low, for both blue and red tanks. Low and high level setting are required to perform the algorithm that was agreed for this demo. We will also add Start Program module to initiate the process once the red button on the control panel is pushed. Step 4 is to create the overall program structure. In this step, the process earlier added will be structured in a flow of execution by the USMC using the hardware modules which were added in Step 3. Step 5 is where we generate the program file using the compiler. The output will be an INI file which can be transferred to an SD card. The result. The SD card containing the program file generated is now slotted into USMC, and reset button is pressed. We are going to press the red button on the control panel now, and the process as programmed will start. Now we can see the blue pump immediately transferring the water into the red tank. It will continue until the level set is reached. Now the level is reached. The pump in the red tank is transferring the water into the blue tank, until the initial water level in blue tank is reached. And this concludes the demo on how USMC can be used to configure analog and digital I/O devices in a very easy and fast way.